In this video, I talk about the range equation. Suppose that a projectile is launched from here. This is its starting point, and its initial velocity is vi, and vix is its initial horizontal velocity. viy is its initial vertical velocity, and the direction of its initial velocity is theta, angle theta above the horizontal line, horizontal plane. And the direction of its initial velocity is theta, angle theta above the horizontal. And this is the trajectory of the projectile. And the projectile lands here. This is its end point. So for such a situation, the height of the initial position is the same as the height of the ending position. So for such a situation, its vertical displacement is 0. Then this one is its horizontal displacement. The horizontal displacement is also called the range of the projectile. So we know this formula. The final vertical velocity square equals the initial velocity multiply sine theta square minus 2 multiply acceleration g multiply the vertical displacement. And for this situation, we know that the vertical displacement is 0. So we get the final vertical velocity square equals the initial velocity multiply sine theta square. So we know that the magnitude of the final vertical velocity equals the initial velocity multiply sine theta. We know the direction of the final vertical velocity is down because at the end the projectile goes this way. So it's the direction of its final vertical velocity is down. It's opposite to the positive direction. So the final vertical velocity equals negative the initial velocity multiply sine theta. We also know this formula. The final vertical velocity equals the initial velocity multiply sine theta, then minus acceleration g multiply time interval delta t. So from this formula, we can get the time interval delta t equals the initial velocity multiply sine theta minus the final vertical velocity over the acceleration g. And we know the final vertical velocity is the negative initial velocity multiply sine theta. So this equals bottom g, top the initial velocity multiply sine theta minus negative initial velocity multiply sine theta, and this equals 2 multiply the initial velocity multiply sine theta over g. So delta t is this guy. Now we also know the range of the projectile is also called the horizontal displacement equals the initial velocity multiply cosine theta multiply delta t time interval. And we replace delta t with this guy. Then this equals initial velocity multiply cosine theta multiply 2 multiply initial velocity multiply sine theta over the acceleration g. So this equals bottom g. The top is initial velocity square multiply 2 multiply sine theta multiply cosine theta. And this equals, we know 2 multiply sine theta multiply cosine theta equals sine 2 theta. So at last, this guy equals bottom g, top initial velocity square multiply sine 2 theta. So the horizontal displacement equals this guy. This is also the formula for the horizontal displacement. This formula has a condition. The condition is that the projectile starts and ends on the same height. The height of the starting point is the same as the height of the ending point. Then we can use this formula to calculate the horizontal displacement. It's also called the range of the projectile. And we also know that when 2 theta equals 90 degree, sine 2 theta has its maximum value. Its maximum value is 1. So when 2 theta equals 90 degree, the horizontal displacement will have its maximum value. When 2 theta equals 90 degree, theta equals 45 degree. So we can know that when theta is 45 degree, the horizontal displacement will get its maximum value. This video tells us that if you want to launch a projectile and want it to go as far as possible, the angle of the initial velocity should be 45 degrees above the horizontal line.